Welcome back. So let's look at those trig functions. There are actually 6 trig functions, but we're only going to be worried about 3 of them. And a trig function is really just proportions. It is fractions, one side of a triangle over another side. So the sine, so we can use the word SOH-CAH-TOA to help us remember those trig functions. So let's start with the sine. So the sine, and we use SIN for short, of our angle, so I'm going to use the letter A, equals the opposite side over the the hypotenuse. So it is the fraction where we take our hypotenuse, and that would be this side here, and we take our opposite side. So first I need to know which one is A. So we're going to let this angle right here be A. We'll do that in all 3 pictures. So the opposite side is this side right here. So those are the 2 sides we're going to use to find the sine. Now the cosine, we'll use COS for short, and then we're going to have our angle, and this is going to be the adjacent side divided by the hypotenuse again. So our adjacent side would be this side right here, and our hypotenuse, which was our longest side. So those are the 2 sides that we're going to use. And then last is our tangent. So that is TAN for short. So the tangent of my angle is the opposite side divided by the adjacent side. So our opposite side would be this one here, and our adjacent side would be this one here. And like I said, this is just a fraction. So the first thing we're going to do today is use those fractions, or just find those fractions, and then we'll learn how to use them next time. So let's start with my first triangle up here. Now note I drew this triangle twice because the opposite and the adjacent depend on the reference angle. So in the left triangle, I want the sine, the cosine, and the tangent for L. So this is my reference. So I'm going to highlight my reference angle. That makes this side the opposite. The longest side is your hypotenuse, and that leaves this side for the adjacent. My sine is the fraction opposite over the hypotenuse. So for this problem, that would make my fraction 12 over 37. Now you can leave it as a fraction, or you can turn it into a decimal. But the fraction is more exact because my decimal is going to be irrational. It's going to continue on forever. So let's look at the next one, L, or cosine. Cosine is the adjacent divided by the hypotenuse. In our problem, the adjacent side was 35, and the hypotenuse was 37. So it's the fraction 35 over 37. And our last one is the tangent. So that would be the opposite side divided by the adjacent side. So my opposite side was 12, and my adjacent side was 35. Now let's use that same triangle, but this time let's let our reference be the angle N. So this one up here is my reference angle. So if I highlight my sides, that's going to make this one here the opposite. The 37 will remain the hypotenuse, and the 12 turns into the adjacent. So notice it's the same triangle, but we have labeled it the opposite. Now our fractions, let's see how they are affected. My sine is still the opposite side divided by the hypotenuse. But notice that this time the opposite was 12 and the hypotenuse was still 37. Uh-oh, that's not right. What was our opposite? For this one, it was 35. So notice that because I changed the reference angle, it changed my fraction. You might notice that these two have the same fraction. Will that always happen? Let's find our cosine of n. So that one would be the adjacent side divided by the hypotenuse. So now our adjacent is 12 and our hypotenuse is 7. Notice the sine of one is the cosine for the other. Lastly, we're going to find our tangent. So that was our opposite side over our adjacent side. So for n, my opposite was 35 and my adjacent was 12. So it is the reciprocal to the other one. Now, any questions on finding those fractions? We're going to use those fractions later on to help us find the missing sides. You know, this one I gave you all three sides. Now let's look at this next one.